Today I'm posting a video about a pulse motor that I've been working on, and this is my trigger wheel down here, and this is the trigger sensor. Now the trigger sensor is made by Honeywell, and right now I'm using it in the NPN wiring sequence, and this is all the specifications for the switch itself. Now what it does is, as the thing spins, it detects these stick-on aluminum pieces down here and triggers my coil, which is right over here. Now, this coil is nothing but an air-wound coil, and this is what it started out as, up here. This is a series ballast out of an old fluorescent light, and you take it apart and you end up with a core like this, which would actually have wire on it, and I made this plastic block to fasten it to the base plate back here so that it'll be secure. Now, this wheel is made out of aluminum over here, and the magnets are north-south configuration. Now originally I only had north magnets on it, and the north magnets, with them on and it running at 10 volts, it drew 48 milliamps. Then I added this south pole magnet right after the north pole magnet, and that dropped it to about 12 milliamps for a draw. It actually becomes like a generator. So if you look, you'll see that this over here, there's a spot where there's like a neutral zone, where there's no real, there it was for a second. Anyways, that is what makes it work efficiently. What happens is over here, when the North Pole magnet gets a little past the center of the coil, we trigger it till the south magnet is even with the coil, then it shuts off. And that kind of makes a generating action and feeds some current back into the system. Now, I'm going to turn this on up here, and it's running on 10 volts right now. And what I'm going to do is, I'm going to come down here and disconnect the input voltage from the coil. Now it's disconnected. Now, when you rotate this and it sees the metal strip, you see the LED lights up and the end of it, and that's what lets you know how many milliamps this thing draws. Is over here, and it draws 18.7 milliamps just to run the circuit. Now I'm going to post another video with it running, and keep in mind how many milliamps that just that trigger circuit drew. And once it's up and running, you see how many milliamps that the thing draws when it's running, and you subtract what that circuit draws. Do the math. That's all I can say. I'll be posting another video in a while. That's it for now.